When trying to determine the equation of a line, I guess the fail-safe method is to just substitute the points that you've been given into the general rule and then solve for A, B, C, D, etc. All right. Often though, if you can be a little bit more intuitive about which form of the rule you use, well then it saves us a lot of time and working. For example, if our cubic equation is a graph where you've been all the intercepts have been labelled, well then this is the form here. Okay, we've clearly got the intercepts. You know roughly what the intercepts are. That's the way in which we would go for it. If one of those intercepts happens to be a turning point, well then either of the forms in two. All right. If by chance you've got a graph that just has the point of inflection labelled, well then we're going to use this point here. If on the off chance you've just been given 4 distinct points, you've got to use that general rule. And it can be time consuming, come up with 4 equations and solve for 4 unknowns. So if we look at example 14, that's similar to that one. That's the method we're going to approach here. All right, so clearly I've just got 4 points, f of 1 equal to 0. So at x equal to 1, y is 0. So I've got one intercept, okay, but I don't have enough of them to warrant using an intercept form. All right, so let's look at this one here. We've got a whole heap of points here. Don't forget there's my y value, there's my x value, my y value, my x value, my y value, my x value. If I substitute 5 in my x value, I end up with 80, the y value. So if we work with the first point here, equation 1, I get 0 is equal to a times 1 cubed plus b times 1 plus c times 1 plus d. So I get a plus b plus c plus d is equal to 0. All right. Equation 2. Y is equal to negative 7 when x is equal to 2. A times 2 cubed. So we're just going to substitute these points in all the way along. So I get 8a plus 4b plus 2c plus d. There's equation 2. Equation 3, I'm going to use the point 27, 4. So 27 is equal to a times 4 cubed, 64a, plus b times 4 squared, which is 16b, plus 4c plus d. Finally, equation 4, I get 80 is equal to 5 substitutes in, 5 cubed, 125a plus 25b plus 5c plus d. Now, we would never expect you to solve this system of 4 equations without a calculator, all right? So that's what we've done here. We've gone down and shown you 2 ways that you can use your case to solve that equation, all right? Big fan, defining the function. Now, really important, you put the time symbol in between. You can't just put ax cubed plus bx squared. It's got to be a times x cubed plus b times x squared, etc., etc. All right, and then you go to menu, algebra, and then down to solve, and you can have system of equations. Okay. Now, it normally defaults to be x and y, your variables. Change them to a, b, c, d, because that's what we're working with, all right? So you can type in the rule this way. I think that's the easiest way. F of 1 is equal to 1, f of 2 equals, etc., etc. Or you can just type in solve and put in each of the conditions with an and in between, all right? But I think this method here is a better one, all right, the first one. Again, I've defined it as f1 of x as opposed to just f of x. The advantage is once we worked out f1 of x and we get those values, that graph will appear in our function f1 of x already. So we get the graph straight away, all right? So if you type those equations in, you'll end up with corresponding a, b, c, and d values, which means then my rule, that's right there, rule answer, whilst it says just to find the values of a, b, c, and d, it doesn't hurt to say that f of x is equal to x cubed plus x squared minus 17x plus 15. So there's my polynomial function there. All right. Have a look at these ones. So this is where I'm talking about how it helps to pick the right form of the equation. All right. So very clearly, we've got a couple of intercepts here. And in fact, this one here is a turning point repeated intercept. So what do I know? I know that y is equal to, if -1 is a solution, x plus 1 is a factor. If 2 is a solution, x minus 2 is a factor. Because it's a turning point, it's x minus 2 squared. So that's those intercepts. All I know now is that I've got some constant at the front, all right, just in case I have a dilation, because there's nothing to say that this graph doesn't go steeply like that, or in fact, I could go negative, yeah? So we need to put an A at the front just to help work out a dilation or if there's any reflections. So to work that out, we use the other bit of information there, the 0.32. So x, y. So I know that 2 is equal to a times the x value, 3 plus 1 times 3 minus 2 squared. 2 is equal to a times 4 times 1. So a is equal to a half. So our equation, y is equal to a half of x plus 1, x minus 2 squared. All right. It's across to b. Sort of cuts a bit short there, doesn't it? So let's just extend that a fraction. We can see here that we've got a negative cubic and there's a point of inflection there. All right, so general form, a equals x minus h all cubed plus k. So y is equal to some constants out of, or it's shifted 1 unit to the left, so it's an x plus 1 all cubed, and 2 units up, so plus 2. All right, now, give thought to what sort of an a value should we be expecting here, and that's really important to consider. Okay, what sort of a cubic? It's a negative cubic, so I'm expecting a to be less than 0. To work out the a value, we substitute 1, -2 in, so -2, and I'll put that there like that. -2 is equal to a outside of 1 plus 1 cubed plus 2. So we substitute the point in. -2 equals a times 2 cubed plus 2. Subtract 2 both sides. 2 cubed is 8. A is equal to -1/2. So negative is a good sign. So the equation, -1/2 x plus 1 all cubed plus 2. So we do the same thing here. They look very similar, these two, but slightly different. Have a look here. We've got a b value that's a turning point and an a value there. Now, normally we would expect on the left-hand side of the vertical axis that b is negative. So I know b is a negative number, but it's been labelled as b, which means y is equal to, now I might put some k out the front so I don't put in the a's and b's there, some constant out the front, x minus b all squared, x minus a. So even though we've moved left and you want to say it should be an x plus b, because b has been labelled as positive, the factor is the negative of that, which makes it x minus b all squared. So there's a general form of the rule there. All right, now we don't have any intercepts or anything like that, so we would probably leave it like that. We don't have any information to work out if there's a dilation. The only thing we could possibly argue, maybe I'll put a negative sign there. I'll change the colour. Maybe we could put a negative sign there because I do know it's a negative cubic. All right. Finally, D, very similar, except they're both on the right-hand side. And the a is a repeated factor this time. So again, y is equal to, I'm going to use a k value, x minus a all squared because it's repeated, times x, started to put a plus, minus b because it's just an intercept. We have no information about to help determine the k value. So again, I might just put y equals negative k, x minus a all squared, x minus b. Okay.